Hello. In this problem, I want to consider the polynomial function given by f of x equals 3x cubed minus 10x squared minus 9x plus 4. I want to list all possible rational functions. I want to find all zeros using synthetic division. I want to find the y-intercept as an ordered pair. And I want to graph this function. Okay, let's start out with the possible rational functions. In this problem, p is 4 and q is 3. In other words, p is the last one and q is the leading coefficient. The factors of 4 are 1 and 4 and 2 and 2. The factors of 3 are 1 and 3. So I do all possible p divided by q's. And so that gives me 1 over 1, 1 over 3, 2 over 1, 2 over 3, and 4 over 1 and 4 over 3. And so I write down all of these simplified, and so that's 1, 1/3, 2, 2/3, 4, and 4/3. Except all of these are plus or minus. Now, some people want to be able to just put a plus or minus at the beginning. Unfortunately, we can't do that. So this is A. This is all possible rational zeros here. Now, look at B. We want to find all zeros using synthetic division, which means we can randomly pick out a number from here and use synthetic division to see if this is a zero of the original function. However, that is a little bit tedious, so what I want you to do is I want you to take your calculator and I want you to type in this function into the calculator. Okay, so go to y equals here. If there is a function there, clear it off. And then type in 3x cubed minus 10x squared minus 9x plus 4. So 3x cubed. Now notice if it automatically puts your exponents up there, you need to go ahead and do the right arrow to get out from your exponent. Minus 10x squared minus 9x plus 4. Now I can go ahead and graph this, and this gives it to me in this form, but I want to see the table. What I'm looking for here are zeros, which means on the y table I need to look for a 0. Notice that there is a 0 here at 4. I know that. If I go up a little bit, I can see that there's a 0 at -1, and there's probably another one, but it's probably a fraction. But I know that 4 and -1 are zeros. So I'm going to prove that using synthetic division. So on B here, I'm going to show that well, let's just do 4 for now. I'm going to show that 4 is a 0. So I'm going to have a 3, -10, -9, and 4. Notice I don't have any zeros here because I'm not missing any degrees. So bring down the 3, multiply, add, multiply, add, and multiply. So it gives you 3, 2, and -1. And notice that I got a 0 at the end. That meant f of 4 equals 0, which means 4 is a 0. By the way, the x-intercept at that point would be 4, 0. Now, we also know -1 is a 0, so I'm going to bring down the 3, multiply, add, multiply, and add. Notice I've just proven that -1 is also a 0. But I now have 3 and -1. As a polynomial, that means 3x minus 1. And if it's a 0, that means that it equals 0, which means I can add 1, which gives me 3x equals 1, and then divide by 3, which gives me x equals 1/3. And that means that 1/3 is also a 0. You can also check this. Now notice that y equals already has the function, so if I go to the home screen here, by doing second quit here, which is the mode button. I go to vars, write 1, enter, enter. Then I can do parentheses of 1 divided by 3, close parentheses, click enter. Notice it gives me a 0. Good. So what that tells me is that my zeros here are -1, 1/3, and 4. C says find the y-intercept as an ordered pair. Well, that's actually pretty simple. That means that I need to find f of 0 because the y-intercept means x equals 0. So this is gone, this is gone, this is gone. All I'm left with here is 4. So my ordered pair is 0, 4. And then I can plot all this. My zeros are -1, which is right there. 1/3, I'm going to have to just kind of approximate here. And 4 is right here. And then I can also plot 0, 4. Now notice the multiplicities for my zeros are all 1 because they're only used once here, which means all of these cross. Also, this is degree 3 with positive out front, which means as you go into the left it goes down, and as you go into the right it goes up. So beyond the last 0 I'm going down, and beyond the last 0 here I'm also going up. That means I cross here, and cross here. And now I just kind of connect everything. There you go. Now notice that this is not an exact graph, but it is a close approximation to what you might see.